Okay.
Perfect.
So for example, let's take this one. You are telling me that you are struggling with this. This is a potential divider circuit, right?
Mm-hmm.
First of all, how you understood what this potential divider does in general terms? Can you describe it to me in a few words? Try it, please.
Honestly, I am
No.
not quite sure.
Sorry,
But
sorry for smiling, but after
no, it's
20,
fine. Don't worry.
after I didn't say anything about myself. I don't want to talk about myself generally,
Oh,
but
don't
I
worry.
have spent 28 years of my life. I am 54 years old.
Yes.
I live in Athens, Greece.
Hmm.
Have you ever been in Greece or not?
No, I haven't been to Greece.
Okay. I think that I have to say that come to Greece for summer, especially for summer vacation.
Mm-hmm.
So I have
Would be
spent
nice.
28 years of my life teaching physics. And one thing I can say for sure is that physics is a complex concept, it's a complex science. But I think that most of teachers and students make the same mistake. They try to understand it in the wrong way. So let's start with this. What is a potential divider? Divider means that I have to divide something, right?
Hmm.
Divide what?
Well, I would guess the potential difference.
Yeah,
Or the
voltage.
voltage, yeah.
Yeah, great. So you have a 12-volt battery. And
Hmm.
when it comes to 12-volt battery, it says the first part. What is meant by the EMF? We call it electromotive force. Can you
Yes.
try to tell me what do you know about this quantity? What is
Right.
an electromotive force? Right.
Um, so we didn't, I don't think, learn this in class, but
Mhm,
from what I've
mhm.
understood, it is the total voltage that a battery, or a cell, I should say,
Uh-huh.
wants to put out.
Great. I would say it can deliver. Okay.
Deliver. Okay.
But my question is simple. Suppose that you go in a market and
Hmm.
buy a small battery for your needs,
Yes.
and you see that it says 12 volts on it, right?
Hmm.
This indication is what we call the EMF. And you go back home and you put this battery, of course 12 volt is too much, but let's say 3 volts for the most common electrical
Yeah.
devices, just like a calculator, let's say.
Hmm.
And you go back, suppose that you have a small lab at home, and you put it, try to connect it to the circuit you want to operate. And you take a voltmeter and you count, you measure the voltage across the device you are talking about. And
Yes.
let's say that you take an indication of 2.2 volts. So
Mm.
what is the truth? 3
Internal
volts?
resistance.
Yeah. And
Yeah.
now you have answered.
Yeah.
The EMF, I would say, let me let me write the definition formula. Can you see this one? Hmm? Can
Work
you,
over
can you go in?
charge.
Yeah, exactly.
Hmm.
It is the work done by the battery per unit of charge to move it inside the circuit. So, in simpler words, EMF is a voltage. It is measured in volts, right?
Hmm.
That it is the theoretical voltage that any battery could deliver to the circuit that it is connected if it doesn't have if it didn't have any kind of internal resistance,
Right.
right?
Right.
But
Okay.
we know that ideal batteries do not exist.
Mm.
Do you know? Just like ideal women, okay? They do not exist. I hope that your mother is not hearing us right.
No, no, no. I have headphones on. No one hears.
Otherwise, she's gonna tell you to find another tutor. So ideal batteries do not exist, but for theoretical purposes, we can say that we can have an ideal cell having zero internal resistance. So
Right.
under these conditions, E would just be what we call, do you know
Voltage.
what
Okay.
how we call? Yeah, it's just a voltage, but
Voltage.
it's terminal voltage. Why do we call it terminal voltage? Do you know?
Is it because that's the total voltage that is lost as it goes around the circuit?
No,
Oh.
terminal has to do with the terminals of the battery.
Oh,
You
right.
know,
Okay.
what we call negative
Yeah.
and positive terminal. That's why whatever is directly connected to the terminals of this battery
Yeah.
It is under a voltage, we call it terminal voltage. Let's go now and discuss about something else. Okay, we have this 12-volt battery. And why should we divide this voltage? Tell me a practical reason for doing this. Hmm?
Mm,
You have to work
yeah.
with a device that is being constructed to work under 6 voltage.
Oh yeah.
If you directly connect 12 to 6, it will be burned out,
It will
right?
explode. Yes.
Explode, right?
Yeah.
So you have to divide the voltage into equal parts.
Right.
That's why
Six.
you take this one. And what is this one? Can you describe me the part? What is AB?
Um. AB. I mean, it says a wire of
Mhm.
uniform
It's
cross
a
section.
uniform. Okay, let's say uniform.
Hmm.
Before moving forward, are you okay with part A?
Yes.
So
Yes.
part A has been explained here. All this discussion.
Hmm.
Of course, one thing I have to apologize, Patrick, is my terrible handwriting.
Oh, please don't worry about that. I can read
I
it very
have
easily.
I have to worry about everything.
Oh,
So,
please.
okay, the problem is here that for part
Yes.
B, it says show that the resistance of the wire AC, just this part,
Hmm.
is 28 ohms. You are given that the resistance of the total wire AB is 80 ohms. What is
Right.
the meaning of uniform? Can you explain it to me?
Means that it's the same for the whole wire.
The same, try to be more precise. When it
Well, the
comes,
same
uh-huh,
cross-sectional area,
not only you have the same cross-sectional area, the
and
same
oh,
density,
and
okay,
therefore resistance, right?
actually the same resistivity. And one thing I want to discuss with you
Ah.
right now, what do you know about resistance in general? We're trying right now, Patrick, to
Hmm.
make a revision of a whole chapter, not
Yes.
just solve a question. So
Yeah.
forgive me if I go from one thing to another, but we have a brainstorming process to recall all the necessary, I would say, quantities and terms and concepts. So try
Yes.
to recall, what do you know about resistance?
Um, Resistance, I would say, is how difficult it is for a
Mhm,
current to go through
mhm,
an
yes.
object. I
Okay.
believe resistivity is how good an object or a resistor is in transporting electrical flow.
Hold on, just one moment,
Yeah, yeah,
if you allow me. Let's take it one by one.
yes.
When we came to discuss about a quantity in physics,
Hmm.
please, you have a list, I'm writing a list, of things you have to worry about.
Yes.
First, definition. Suppose that I'm asking you, give me the definition of a table. A table is something which may have 4 legs,
Yeah.
right?
Hmm.
But this is just a definition. Second one, B, characteristics, which means for resistance. Okay, if we say the definition of resistance is voltage over current, are you familiar with this?
Yes. Yes.
So if I ask you, give me the definition of resistance, you don't have to say what you just said, the
Mm,
difficulty of flowing
yeah.
charges, no. The characteristics and the physical meaning is something different. And here it comes to difficulty you just referred to.
Yeah.
So the difficulty of passing through a wire is the physical meaning of resistance, and that's where the word resist comes from. Resisting to which? Resisting to the flow of the electrons through the cations of the metal wire. Do you agree?
Yes. Yeah. Yes.
But what about the characteristics? Are you familiar with this
Yes.
formula?
I am.
Okay, let's discuss about it now. When
Hmm.
I say characteristic or features, it's up to you.
Hmm.
I mean that which features, which some quantities, I would say, which quantities the resistance depends on. We have three: resistivity, length, and cross-sectional area, right?
Hmm.
And obviously, we have experimentally found that resistance is directly proportional to the length inversely proportional to the cross-sectional area and also proportional to resistivity, right? So in order to finish that, tell me, what do you know about resistivity? Which other quantities determine the resistivity? Do you know?
I don't know.
First, the material. The resistivity of copper is different from iron. It has to do with the internal chemical structure, right?
Okay.
I would say the size of the ions, their mobility, how fast they can move or not, their distances, and other features that there's no reason to discuss about it right now. Another quantity is the temperature. So